Okay, so for this video, we will continue with the equation of the straight line. Okay, and also some important concept that you need to know in order to apply in the question. Okay, so first you need to know how to find the equation of a straight line given sufficient information. So usually they will give you the sufficient information, but generally in short, you need two things here. The first one is you need to have the coordinate of points and also the gradient. Okay, so to interpret and use the linear equation, you also need to know how to form the equation. This is the formula that we use to form the equation, to form the linear equation. And after that, after you form a linear equation, maybe you need to know also how to apply it. Okay, so let's start. Okay, so let's start with our first part here. Then again, to form the equation of the line. Okay, so generally what you need to know is you need two important things here. The first one is the gradient. And then the second one is a point that passes through the line. So usually I'll call it as the passing point. Okay, so you need these two things here. So the gradient and the passing point is the basic for you to form the equation, linear equation. Alright, so when you want to form the linear equation, generally there are a few ways for you to do it. For me, generally I'm using y minus y1 equals to mx minus x1. So the y and y1 and the x1 are the coordinate that you get in the passing point in the question. Okay, and after that, some of you may want to use y equals to mx plus c, where you try to find the value of c first and then you rewrite the equation again. So both are accepted. Alright, so for me, I will focus on this formula. I'm using this formula all the while. Both are correct actually. Alright. Okay, then what else do we have? Okay, so the general equation of a straight line is ax plus by plus c equals to 0. Okay, and then what else is important here? Okay, so to test if a point lies on the line or curve or not, generally you have to substitute the value of the coordinates into the equation. If let's say the left-hand side value equals to the right-hand side of the equation, then that means that the point lies in the line or lies in the curve. If let's say left and right have different value, that means the point doesn't lie on the line or doesn't lie on the curve. Okay, so again, all these are some very basic concept and idea that you need to know, okay, about the linear equation, the y equals to mx plus c. Okay, then next one. Sometimes you will need to count the shortest distance from a point to a line. Okay, so the shortest distance got another name. We also call it as perpendicular distance. Okay, so what we call it as perpendicular distance is because of generally, the shortest distance always appears at the 90 degree, okay, of the straight line to the point, to the line, to the horizontal line. So it is 90 degree to each. So if I want to find the shortest distance, which is this one, the D, okay, from a point to the line, okay, so the formula is given. You need to maybe try to memorize it because I don't think that this is provided in your formula booklet. Okay, and then to use the formula, first you need to have the equation of the line first. Okay, the equation of the line, and you have to rephrase it in the general equation. Okay, so when you put it in the general equation already, ax plus by plus c, when you want to apply it in the formula, the x and y, you substitute it by using the point that you want to get the perpendicular distance from the line. Okay, so you substitute the coordinate of the point that you want. Okay, because you want to find P, the shortest distance from the P to the line, right? Okay, and then to get the distance, you need to substitute H and K, the coordinate of P, inside the general equation that we have for the line, and then you get divided by square root of a squared plus b squared. So the a squared is the coefficient of x, b squared is the coefficient of y. And then I put a modular sign here because for distance part, generally it should be positive for distance. So if you, in case you get a negative value for the whole answer, you just really change it become positive. Okay. So let's have a look for some example that discuss about the shortest distance. Okay, so example 4. They want you to find the distance of this point to this straight line. So this is the point and this is a line. Therefore, the formula for the distance is what? It is actually 3x plus 4y plus 7 divided by the square root of a square, which is 3 square plus 4 square. So to get the value, you substitute the coordinate into the x and also the y. So you should have 3 times 2 plus 4 times 3 plus 7 and then divided by, at the bottom part here, if you try to simplify, you get a 5. Okay, so if you continue further, then you have 25 over 5 and it is equals to 5. So the distance between the point and the line should be 5 units. Okay, so this is how we actually apply the distance formula and the shortest distance formula from a point to a line. Okay, so now we make it slightly harder. If let's say I want you to find the shortest distance between this line and also this line. Okay, so now if let's say I want to find the distance between two lines, right? It looks like not so easy for you to do it because actually the formula applied is for a point to a line. But now you're having two lines here. Therefore, to find the shortest distance between two lines, you need to slightly do a small adjustment here. Okay, so before that, I just want you to have a look here. If you rephrase this equation, you have 12y equals to 5x minus 5. So y is equals to 5 over 12x minus 5 over 12. So for this equation, if you try to rephrase it, then what do you have here? If you rephrase this equation, then you have 12y equals to 5x plus 21, and then y equals to 5 over 12x plus 21 over 12. So this both equation here is in terms of is in the pattern of y equals to mx plus c, right? Okay, so if you compare it with the equation y equals to mx plus c, what does it mean? Okay, so what is the gradient that you have? So you get the gradient that you have here is actually 5 over 12, right? If you compare. So this gradient is equals to 5 over 12. This gradient is also equals to 5 over 12. That means what? That means that both lines are actually parallel to each other. Okay, so because of this, so this and this are parallel. The question didn't tell you that, but you should observe it yourself from the equation of the straight line. Okay, and after that, you try to, because you know that they are parallel to each other already, am I right? Okay, so assume that this is 5x minus 12y plus 21 equals to 0. Then another line here is 5x minus 12y minus 5 equals to 0. So you see that actually I didn't go and sketch it out in detail. I don't need any point to sketch a graph. I just simply draw it because what I know is these two lines are perpendicular to each are parallel to each other. That's it. So I just draw the two parallel lines. Okay. Then now, if I want to find any point on the line, how can I get any point on the line here? Okay, so to get any point on the line, you simply let x equals to a value. It depends on you, which one you want. Or maybe you can substitute any value to the y. Because I want to know any point. So if let's say this line will pass through any value of the x and y also. But okay, if let's say the line pass through the y, if the line pass through the y, what is the value for the x? Okay, so if you have let y equals to 0, so for this equation, you want to let the y equals to 0. So you have 5x minus 5 equals to 0, and therefore your x is 1. So that means if you let y equals to 0 and you get the line, the value x equals to 1, means that this particular point here is actually 1 and 0. Okay, alright. So I try to find out one point on the line first, and after that, by using this point, I want to find out the perpendicular distance from this point to the line. So if I find the perpendicular distance from this point to the line, that means it is actually the distance between the line also, correct or not? Because they are parallel. So the point to line distance is also the distance between these two lines. Okay, alright, so now I'll start with my distance now. So what's the distance formula here? You have to write 5x minus 12y plus 21, then divided by the square root of 5 square plus 12 square. Okay, so the formula that we get it just now. Okay, and after that, let us continue. The x and the y here, you need to substitute with the point that you want to find out the distance between the lines. Okay, so you substitute 5, and then the x just now you found is a 1, right? Minus 12, y is 0, plus 21, and then divided by square root 5 square plus 12 square, you should get a 13. Okay, so if you continue further, 5 plus 21, you get 26, and then divided by 30. Therefore, the distance between the two lines is equals to 2, so 2 units. Okay, so this one, if compare it with the previous example just now, it is slightly harder because they actually want you to find out the distance between two lines, but you just do some simple adjustment, then you can actually apply the formula also. Okay, so this is what you have for the shortest distance formula. Again, maybe in AS level, if you didn't apply this formula, you might also need to use it in A2 level. So all the concept, all the formula that we are learning now, right, we might use it somewhere else, sometime else. Just that maybe not AS, then you should be able to apply it in A2. All right, so don't ignore every single formula that I teach you here. Okay, all right, then let's continue further. Sometimes the question will ask you to find the area of the plane. Okay, but I don't think that this one we use it very often, but I think you learned it before, right? Okay, so I just recall back. So there's no formula, there's no example about the area of the plane. Okay, but if let's say in the future, if you want to use it, then you can try to use. So when you're having 3 coordinates and you want to find the area, then generally what you need to do is you need to arrange the coordinate. Okay, A, B, C, and then repeat A again. Okay, and after that, to calculate the area, you take x1 multiply y2 plus x2 multiply with y3 plus this one, then minus everything on top. So I think you need to think a way to memorize it. Most of you learned this before, I believe, just that I'm afraid that you all forget. So I just attach it here in case you need to use it in the exam question or exam paper question. All right. Okay, then when you're having the more points, the same thing happens here. Okay, which is the general formula for you to find out the area of plate. Okay, then so generally we already learned most of the concept that we need to apply in the coordinate geometry. But before we go into the passive question again, there's one more part that is quite important. I think it's quite useful for you to refer. Okay, so if you scroll down to the end of this chapter, I give you a part which is the extra notes. I hope that you can see this. This is the extra notes here. All right. So you need to know some properties of the different types of quadrilateral or maybe different shapes. Okay, some property in the shapes is quite useful. All right. If you want to use it to answer some of the questions. Okay, so as an example here, we can have a look for rectangle. Okay, so this is rectangle, right? Okay, so look at the rectangle. What are the properties here? all the interior angles are right angle. So all the angle here are right angle. Okay, but you know all these facts lah. But how can you use this fact to answer the question maybe? Okay, so if I say all the interior angle are right angle, that means you can form a few equations from here. You can actually know that the gradient of AD multiplied with the gradient of DC is equals to -1. AD and DC. Or maybe you can have the gradient of AD multiplied with gradient of BC, it is equals to -1. And so on. There are a few equations here for. Okay, so when you're having a rectangle, that means some useful information is you can maybe use this to help you to answer the question. All right. Okay, so this is the first thing that you need to know. When you are having all the right angle, means you link it with the gradient. Multiply with gradient equals to -1. Okay, then what else? What is the second property? So the second property here is opposite sides are parallel. So opposite means that AB and DC are parallel. So if let's say when you know that AB and DC are parallel, that means you can use the idea that the gradient of AB should be equals to the gradient of DC. Okay, or the gradient of AD should be equals to the gradient of BC because they are parallel to each other. So this is the second property that is useful for us. Okay, then the third one is equal in length. So the opposite side is equal in length. This that the AB length should be equals to the DC length, or maybe the length of AD should be equals to the length of BC. Okay, all right. So you have three properties here already lah, and you can try to link all the properties with the concept that we learned just now. So this is a formula for distance. So if you want to apply this property, this is a formula for distance. This is the formula for gradient. This is also the formula for gradient, but this is perpendicular, so it is equal to -1 when you multiply two gradient together. This one is parallel, so the gradient AD should be equal to the gradient of BC. So you see all the property here will link you to some concept or formula that we learned just now. So you need to know how to link it and use it in the exam or use it in the question. Okay, then the other one is diagonal are equal in length. Okay, so what's the meaning of diagonal are equal in length? So diagonal means this one. When you try to connect A to C, so the line AC, we call it as diagonal. So you have two diagonal here, BD and also AC. All right. Okay, so when you're having BD and also AC, the diagonal are equal in length. So that means again, when you look at this property, it should be AC equals to BD. The length are the same. So this is a question of the distance. And also bisect each other. So when you see the word bisect each other, means that these two lines, the intersection point of the two lines is actually the midpoint of each other. So the word bisect tells you that their midpoint are the same. So that means you are having midpoint of AC, it is equals to the midpoint of BD. Okay, so again, this property will link with the midpoint formula that we learned. Okay, so there are so many properties, right? Which one is very useful in the exam actually? Okay, so usually my suggestion is like that. If you go through with all the steps later, right? If you see any property with diagonal bisect each other, usually this is the first priority of the information that I prefer students to use. And it is easiest to be used. Okay, so this is the first one. All right, and then after that, the second one is you can focus on all the equation that is related to gradient. If let's say you don't have any information about diagonal, then you have the information about the gradient. Try to use the gradient to solve your question. And the last priority is the length. So usually I will tell students, when you want to answer the question, right, try to avoid the equation of the length. Because when you have equation of length, usually the equation become very complicated because you need to square it and then you need to take square root and so on, right? That end up most of the time, students will lost somewhere and they cannot have a solution or cannot get an answer that they want. Okay, so usually select the correct property to be applied in the question is important. So again, please put this as a first priority. Diagonal bisect each other, which means the midpoint of AC equals to mid PD. Put it in the first one. The second priority is the gradient. And last one, only you consider the formula of the distance or formula of length. Okay, so this is the rectangle. Okay, then if you continue further, square more or less the same. Alright, so you can have a look yourself here. And then maybe parallelogram. Okay, so again, the same thing here. Parallelogram opposite side are parallel and equal in length. So parallel means the gradient. Length means the formula of distance. And then diagonal bisect each other. So again, this one talk about midpoint. So if they want you to answer any question related to this one, then also you first apply the diagonal bisect each other property first, then followed by gradient, followed by distance. Okay, so for all the property here, I'm not going through in detail with you. You have a look here. So all the property is listed down. So you can just try to have a look. And then for rhombus, got one special one. Okay, so for rhombus, right, there's one special properties. The diagonal bisect each other, and also it is 90 degrees to each other. So that means you have one extra property for rhombus. Then the rest you just go back and have a look. Okay, you can just go and refer it and then to see which one is useful for you to apply. Okay, so this property part, just go through it. No need to purposely go and memorize, but just roughly know, okay, all the properties for the important shapes and how you link it with the coordinate concept that you learned before. Okay, like gradient, distance, and also the midpoint. Okay, all right. So if there's no problem, then I'm here for this video first because all these are about the discussion, right? Okay, then for the next video, I will discuss the partial question, a few partial questions, not all, a few only. Okay, so a few partial questions to discuss it with you. All right, then we'll stop here for the video, for this video first.